Welcome to this first class in physics titled Simple Harmonic Motion. Simple harmonic motion. In our first video in physics, the first video, we did motion and types of motion. And under those type of motion, we did translational, which is moving on a straight path, rotational, and we did oscillatory motion. And we said that an oscillatory motion is a type of motion in which the particle will repeat itself at a constant time interval. Now we want to study that type of motion to detail. If I take a pendulum, or if I take a stone, this is the rope, and I tie it to a point, then I swing this stone, what will happen? I will discover that this stone will move up, right, and it will move backwards. It will move like this and it will move like this. Now this type of motion is called a simple harmonic motion. It's a motion of a particle that repeats itself at a regular time interval. For example, if I count 1, 2 to go like this, 1, 2 to go like this, 1, 2, 1, 2, 1, 2, 1, 2. This is what we call a simple harmonic motion. A simple harmonic motion, right? Now, examples of body that experience simple harmonic motion. Example is a pendulum, like what we just explained, a pendulum. Another example is a mass-loaded spring. For example, let's take a spring now and tie it to a body of mass M. If I displace this body down, if I draw down this body, what will happen is that this swing will begin to oscillate. It will begin to undergo what we call compression and expansion, right? It will go down, it will go up, down, up. This type of motion also is a simple harmonic motion. Now let's go to textbook's definition of simple harmonic motion. The first type of definition of a simple harmonic motion is that a simple harmonic motion is the motion of a body, listen very carefully, whose number one, acceleration, right? Or we explain those concepts very carefully. Just make sure you listen. Whose acceleration, number one, is proportional. Whose acceleration is proportional to its displacement. Displacement, number one. And number two, whose acceleration is directed towards the equilibrium position. Throughout this topic, I will use the simple pendulum as an example because it's more easier to explain with. So the first one is that the acceleration, this is definition, textbook definition, and it's also important in exam. A simple harmonic motion, write this down, is the motion of a body in which the acceleration is proportional to its displacement. Also, its acceleration is directed towards the equilibrium position. Let me explain this very carefully. If I take a pendulum bob, right, like this now, okay, if I take a pendulum bob and I take the rope around this side, right, then I lift the rope and I allow it to swing. It will begin to swing up and it come back again, up and it come back again, right? Now the acceleration is proportional to its displacement. What is acceleration? Acceleration is defined, are you getting it now? Acceleration is defined as the change in velocity. For simplicity, acceleration is how its velocity slow down, right? How you slow down velocity or increase your velocity. I know what is velocity. Velocity is how fast you move a displacement. So how you slow down is acceleration, or how you fast down, or how you increase your speed. Are you getting it now? Both of them are acceleration. So the slowing down of acceleration is called deceleration. Don't worry, that is on our former video. So now let this bulb begin to go down. Remember, as it's going down, it's moving along what we call displacement, right? So as it's going down, the speed of this bulb begin to increase. That's acceleration, right? So it means that the more the bulb is moving, which is displacement, the more its speed begin to what? Increase. And that increase in speed is the acceleration. So we say that the acceleration of the body is proportional. It means that the more the movement, the more the acceleration. Are you getting it now? Of the body. Now when the body is going like this, when it's going up, what is happening? It is decreasing in speed, right? Which is also acceleration, negative acceleration. Now this point is called equilibrium position. Are you getting it now? So the acceleration is also directed towards the equilibrium position, because when it's coming like this, it's coming towards the equilibrium position. When it's going like this, it's coming towards the equilibrium position. There's a time it will get to, it will slow and slow and slow, and it will arrive safely at this point. The equilibrium position is the point of rest where there is no motion. Are you getting it now? All right. So let's begin to understand some things some things associated with this simple harmonic motion. Now, if I take a pendulum, right? Are you getting it now? So we have finished the definition. If I take a pendulum, this is the equilibrium position. Then if I swing it, let's assume the pendulum move like this, and it also move like this, right? This is very, very important. This one is called A max. What is A max? Amplitude. We explain what is amplitude later. This is what we call equilibrium position, 0. In this place, the velocity is 0. And also this place is called A max. Are you getting it now? All right. Now we can represent this, or let's leave that for now. Now, what is A? Amplitude. Amplitude, you can write down. Amplitude is the maximum displacement from rest or the equilibrium position. The highest height this body can reach is the amplitude, right? So let's say we take another pendulum and we displace it, and the height it can reach is this place. This place will be the amplitude. Or you increase it with a lot of force and it go to this point. This point is the amplitude. The highest height the body can reach before it starts returning backward is called what? The amplitude. Are you getting it now? So write down amplitude is the maximum displacement from rest. Write it down. Is the maximum, right? The maximum displacement from rest or the equilibrium position. So after amplitude, the next thing we'll talk about is called frequency. Those things are very important. Frequency. What is frequency of a simple harmonic oscillator? The frequency of a simple harmonic motion, are you getting it now, is the number of oscillation. Write those things down. Is the number of oscillation performed per unit time. What is unit time? Unit time is the same thing as 1 second. So it means that the number of oscillation performed in 1 second is called frequency. Now you might ask, what is oscillation? Oscillation, for example, is a complete cycle movement. Let's say this bulb now move from here to this point, right, and come back again to this point, right, and goes to this point, right, and come back again. It just move one oscillation. So one oscillation is like a complete cycle movement. You go, come back, move again, comes back, is what we call an oscillation. So how many oscillations, how many times it moves, come back, move, come back. This is 1 time. In how many times it does that oscillation in 1 second is called frequency. Are you getting it now? All right, now the next one we'll talk about is called period. What is period? Period. The symbol for period is T. What is period? Period is defined as the time taken to perform one oscillation, right? Is the time taken to perform one oscillation. Now, in the next class, we are going to be going to the mathematical aspect of this simple harmonic motion when I will be dropping a lot of formulas. So period is the time taken to perform one oscillation. I think now period is T. Simple frequency is F. So you hope you are writing that formula, that definition down. Time taken to perform an oscillation, that is period. While frequency is the number of oscillation per unit time. Make sure you know this difference. Now there's a formula between period and frequency, which is T is equal to 1 over F. The unit for period is in seconds. The unit for period is in seconds, while the unit for frequency is in hertz. Make sure you know those things. They are very, very important, right? Okay, now since we have done period, frequency, and we have done amplitude, I think we will come to the end of part 1. In the next class, we'll be talking. Don't miss the next class. The next class is very important. We'll be explaining things like velocity, angular velocity. We'll be explaining things like acceleration and a lot more. Thank you very much. God bless you.